Okay, welcome back to another thrilling encounter. In this session, I'm just going to show you how to use um, SOLIDWORKS MBD to annotate this model. Okay, so you should have looked already at, and we should already have worked out the tolerance values and the position tolerances and everything else for the bearings, and how to set up your datum system off the flat face and the two dowel holes to then be able to correctly position the bearings relative to the datum system. So the first thing we need to do is to hide all this construction geometry and visible sketches so it's out of the way. So no further ado, we're just going to hide that, and I'm then going to hide this sketch here. Here we go, hidden. So we want to say that this surface here is going to be a datum A, and it's going to be flat. So let's mark it up. So geometric tolerance, it's going to be flat. How flat is it going to be? We're going to go with, let's say, 10 microns. That will do. Don't forget, you can't put anything in here because it's not flat to something, it's just flat. Okay, so we're going to apply that to that face there and pull it out, and it's flat. It's flat to 10 microns. So you essentially, all of the surface must be constrained between two parallel planes with 10 microns between them. So all of the surface must be constrained between it. So it's a bit like if you draw a mountain range and you've got a peak to valley height of 10 microns. It's not a very tall mountain, is it? So there's our annotation. Now, with this annotation, we could have it out at an angle like that, or you could have it straight down like that. But the trouble is it suddenly turns this arrow, this circle, into an arrow, but it should only be an arrow if you're pointing at an edge. We're not pointing at an edge. So let's put the circle back on. There we go. If you want, you could have it in this plane. If you want to do that, we could just select it, and we'll right click, and we'll go select annotation view, and we'll put it in the front view like this. Okay, so you can relocate the annotation to how you want it. So let's put this back where it should be, or where I want it, not necessarily where it should be, it's where it's going for mine. I might move that later, but essentially that's marking up that surface. Okay. Now, as you go along, you can click on this button here that says show tolerance status. You can see that we've fully constrained that surface. We're going to be using that surface as a datum. So let's mark it up as a datum. You'll notice as soon as I click that, look over here, do I want a plane, or do I want to set a width feature or a compound plane? I just want a plane. It's just this surface that we're using as datum A. There you go. We've got two dowel holes. So let's specify something about their size. They're going to be undersized relative to the pin, because we want an interference fit. And if we remember what we did with the pins that are going in there, they're on M6 tolerance. So that if I recall, that's between about 4 and 12 microns oversized. So if this is an aluminium housing, you want, 15 to 20 microns of interference on that. So let's set up a size dimension, and we'll pick up on our hole feature, and we'll drag this out. Before we do, we don't want this pattern. We don't want it to say 2 by, because they're two independent features and they're constrained separately. So be really careful. You can either mark it up as a hole or a cylindrical feature. I would say let's just mark it up as a hole, and that way the dimension will also, rather the specification, will also include the depth. Right, so let's set the hole diameter. It needs to be a tolerance fit, so we're going to go fit and show the tolerance as well. We're going to put the tolerance in parentheses, and we're going to set the hole fit to give us an interference between the pin, on the pin. So if we went with a normal hole fit, which would be something like a H6 or something, just going to increase the significant figures on the tolerance. There we go. We'd have up to 8 microns oversized. So our M6 dowel would kind of be a very loose transition fit, not really what we want. So we need to change that, and if we go further up the alphabet, you get more interference. Let's have a look. Something like an N6. We're now undersized by 5, between 5 and 13 microns, which gives us about between 9 and 25 microns of interference. That's probably okay. If you want a bit more interference, go up to something like a P6. You're then starting to maybe get a little bit too much interference, so an N6 will probably do the job for this. N6 or even an N7, you know, what the heck. Let's go with an N6. Okay. Need the envelope requirement on there, and that goes in after the hole diameter, not after the depth, after the hole diameter. So we're just going to drop that in. So more symbols, envelope requirement, there you go. And we need to set this tolerance here. At the moment it's 8 plus or minus 5 mil for the depth. Sorry, plus or minus half a millimeters for the depth. And that's probably okay. If you want to set the whole depth to a different value, we can just change it here from symmetric maybe to bilateral, and we'll say that it can be deeper but not shallower. Okay, and for some reason it's screwed that up, so let's get back in there. I don't know why it does that. Obviously something wrong there, but you know, SolidWorks being SolidWorks can be a bit like that, can't it? So there's our hole size. We also want to put a geometric tolerance on that, because we need to say how perpendicular is that going to be to this flat surface. So geometric tolerance, perpendicular, and you'd expect a milling machine to be reasonably capable of giving you 5 microns of perpendicularity, or 10 microns. It should be very, very, you know, easy. And what's it perpendicular to? It's perpendicular to the flat surface, which is datum A. There we go. We can either attach it directly here, or we can attach it to the hole. Makes no difference. Okay, so let's attach it to the hole, like so. Okay, and you can see that it's rebuilt itself as a single block of information. So it's got the size of the hole, the dimensional tolerance, control of form through the envelope requirement, and the depth of the hole, and that it's perpendicular to datum A. As we zoom in and out, you'll see the text relative to the model gets bigger and smaller. We don't want that to happen. So let's lock that text size. We go into annotations, right click on annotations and go details, we can lock the text scale. So let's try, see what 1:1 looks like. It looks like that. Probably be okay with that, but if you can, change that to 2:1. Does that get bigger or smaller? That gets bigger, that's no good. Let's go 1:2. Apply. That's more like it. That's what we want. So just rearrange that. There we go. And we can tidy all this up as we go along, or we can wait till the end and tidy it up. So there's our next lot of features done. We need to control this one. What are we going to control it from? Well, it's controlled from this face, and it's controlled from our first hole. So we've got to mark this up as a datum then, haven't we? So again, you can't attach it to the text. You have to attach it to the feature. As you can see, it will lock to it. And we'll do this one here as well. So again, size. Again, we don't want it to say 2 by, so don't use this, use this. There we go. And we're going to set up with a, I'll set the whole depth first. I'm going to go bilateral. I can go deeper by 0.5 millimeter, but not shallower. There we go. And then I need to set up a hole diameter. 3 significant figures, parenthesis turned on, fit with tolerance, and it's going to be the same tolerance as the other one, because again it's going to be an interference fit. I think we used N6 for that. There we go. And we'll stick our envelope requirement in there as well. There we go. Job done. So there's that whole size completed. Now we now need to stick a geometric tolerance on there. This time we're using position because it's perpendicular to the face, but it's also located from the other dowel hole. So it's perpendicular to what? Perpendicular to the datum A. It's located from datum B. The tolerance zone is cylindrical, and our tolerance value, you should be able to do that to 10 microns. So we're going to drop that on there like that. Click OK. Just need to go back and check. You see, I haven't set that with a cylindrical tolerance zone. If you don't, you can just double click on it, and you can just hopefully edit that. There we go. So that's this one set up, and we need to set this up as datum C, so everything else can be measured from our datum set, because if we think about the real component, it locates these holes, which are then locating the shafts and the bearings relative to the other casing. And that information of relativity from one casing to another is translated through the dowel holes. That's the thing that locks the two casings together, or locates them relative to each other, those two dowel holes. So everything needs to be measured off the dowel holes. And when the two casings come together, they're coming together on this face. So therefore you need to be measuring from that face. So let's have a look at our bearing holes. Now, because I've got the step in them, when we go to use geometric tolerance on them for their position, it will that'll be fine, but if we go to do a position on this bottom face here, it will have some difficulty if we've used the wrong type of size dimension for the hole. If we go in and have a look at the size dimension as we go to create it, this hole here, see this it wants to do like a compound hole and select all of the surfaces. I don't want to do that. I don't want them all collected as a single feature. Okay, that will just be bonkers. Okay, we don't want to do that because we don't want to be thinking about the depth of this relative to this face here. It has nothing to do with this face. The location of this face is not controlled by this one, it's controlled by this one. So there's no point in having this as 26 plus or minus 0.2, 9 mil plus or minus a half deep. Completely crazy. If we use this hole selection here, again, we still got this hole depth marked up on the markup, which is no good. We don't want that on there. Not only that, even if we removed it from the markup, it would still be locked in the model-based definition file as being part of the hole. So instead of using the hole markup, we need to use this cylinder markup. When we use the cylinder markup, it's not just for external cylinders like it kind of implies by the icon. It's internal and external cylindrical features, like so. Now you can see that we're no longer got any reference to depth. Depth is completely irrelevant for marking out the diameter of this hole because we're not measuring the hole from this face, we're measuring it from datum A. So there's our hole size. We need to set that up as a toleranced hole. So we've got fit with tolerance. What fit do we want on there? Well, if we remember what we looked at on the SKF website and the data in their online handbook, it suggests particular hole tolerances for the to match the diameters of the bearings to give you a theoretical level of clearance. And I believe, off the top of my head, I think that was H6 and H7. Okay, so I'm going to use I'm going to be awkward and use H7. Again, we've only got 2 decimal places there. Let's up this to 3. Then we've got the full tolerance value in there. We need to remember to put the envelope requirement on. There we go. So there's my size. We could go through and do the others as well, but it takes some time to go through and set each one up individually. I should set up some presets for this really. You could do the same if you wanted to. Set up some presets and save the presets in here so that maybe you have like a hole tolerance setting and you can just choose that and it will set it up, and then you can just maybe change this value. But you could preset it, couldn't you? So you don't have to go through this whole rigmarole like this. There we go. So I'm just going to maybe just do 2 for now. And then we need to control those for location relative to the datum system. So actually let's put on this third one and I'll show you how easy this is going to be. So again, we just want H6 or H7 or whatever You know, I'll probably change that to H7 in a minute. Put parenthesis on envelope requirements. So these are just our preliminary settings, and then we can do once we've put on the rest of the data and we've done our calculations, we can then maybe we have to adjust these depending on what happens when you do your tolerance stack calculation. So there's my hole sizes. So all the hole sizes are now done. So let's quick check on here and we'll see what's now controlled. You'll see that those holes are marked up as yellow, so they're partially controlled, not fully controlled, partially controlled. So I'll leave that turned on and watch what happens when I drop the tolerances on there. So I'm going to use position I'm going to put 10 microns on these. Don't forget the cylindrical tolerance zone. What are we constraining this by? Well, the locations of those are locked relative to the other gearbox housing are controlled by how the gearbox halves go together. So it's A, B and C. You should always replicate the functionality of your assembly through the component and through the tolerancing scheme. Your tolerancing scheme should always replicate the functionality. So we'll drop that on there, that on there, that on there. So it's done all three in one go. Okay. We can also, let's just change this value. We should also be able to control these surfaces here. Now in the past, SolidWorks hasn't liked controlling planar surfaces using position. I don't know whether it's still misbehaves like that, but I'm going to put it onto a profiler surface anyway, just in case. It'll mean the same thing. And I can click on that one. I can click on that one. Ah, don't forget to put the plane on. I missed that on the first one, didn't I? Don't forget to set it to plane. So I'm probably going to have to delete one in a minute. Plane. There we go. Click OK. So we can adjust where some, there it is, that's the one that needs to go, isn't it? There we go. So these ones are planar, you see. I want them to stick out, so I'm probably going to move this one. We just right click on it, select annotation. I'm going to go with front. This one, select annotation, front. This one, select annotation, front. So they're a bit messy at the moment. Let's just set that one up there. That one up. There. And this one here. So they're now locked to those surfaces. Let's just check to make sure they're circles. Yes, they are. That's fine. So that's pretty much all of the functional surfaces controlled. Okay. Let's turn this on. There we go. Oh, we've got some missing. What's going on here? Ah, it's where I deleted the other one, wasn't it? Yeah. So let's just go back and find out what's happening here. That. Delete. Yes. Now let's check it. There we go. Because I had that counter bore inserted, but which doesn't exist. Now the rest of the surfaces can be controlled with a profiler surface all over, and you simply select all the remaining geometry, point at it with a geometric tolerance, stick the two circles on, profile surface all over. Now SolidWorks also has its own general profile tolerance, okay, which you could insert there, but there's no such thing in international standards. So although it might be there on the toolbar, technically you can't use it, which is nice. And so that's pretty much everything done there. Yeah, brilliant.